Hello YouTube, time for part 4. Ready or not, here I am again, ready to bring some eternal wisdom your way. Today we will code the aimbot of our sheet menu. That's right, after today's video you will have your very own working aimbot to wipe the zombies with. This is part 4 of the Left 4 Dead 2 multi-sheet series, and you should be proud of yourself if you can make it through this episode. If you're a new viewer, then I deeply recommend to watch all of the episodes in order. This video should be in a playlist with them. And if you haven't already, hit the subscribe button, hit the like button, write a comment. This is how you can help me continue to create content. At this point, you know that the full project source code will be available in the cover page and you can join the Discord. So let's get right into today's showcase. Let's take a look at what you will have at the end of this tutorial. So we will have written all of the code needed for the aimbot. So literally at the end of this tutorial, if we run start, you will have this, a menu with an option for the aimbot, and if you check it and we go in game, and you hold the aimbot key, it will aim at the closest zombie. Then you just need to hold M1, mouse 1, and shoot. So, I hope that you guys enjoy this. And we're once again, like always, back at the desktop. I have a different background now, but it's still a swedz tutorial. Now, where we left off last time was something like this. We had our imports, we had our draw menu, we had our main, and we had our render. But we didn't have, or we didn't go further than that. So in this tutorial, we will actually go from this point to having an aimbot ready. And to do that, we will need to add that as an option to our draw menu method. So let's do that really quick. In our draw menu, we will firstly add a tab bar, because in the showcase you guys saw that we had a color tab for the ESP. So we will just do this in the beginning so we don't have to change it later. Let's call this tabs, and within these tabs we will add an if and then IMGUI dot begin tab item. So this will be the first tab that holds the checkboxes that you saw, and we will call that general. So within this general tab item, we will have one checkbox, IMGUI dot checkbox. This checkbox will have the label aimbot, and we need a boolean that will hold whether we have selected the aimbot or not. So let's add, we didn't have that. Let's add a new class variable. So we will add this comment above it, just telling us that IMGUI variables, I don't know. But under this, we will write bool enable aimbots. Now, I will set this to true because I want it enabled when I start the application. You can set it to false if you don't want that to be the case. So we'll set it to true, and then we will refer to it in this checkbox. So enable aimbot like this. All right. Now tabs. Forget my typo. All right. Let's add or end this tab item. IMGUI.tab item and tab item, and create a new tab item. IMGUI.begin tab item. Here we write colors because it's the ESP we will configure here. So let's leave it empty for now. And let's end it as well. IMGUI.end tab item. There we go. That should be inside. And we finally end the tab bar. So IMGUI.end tab bar like this. Now let's see if, and let me just add the comments to the swedz init like that. We'll run our application. We should have a checkbox now with an aimbot here like that. We have this colors tab, but it don't really work because we haven't added anything yet, but we have a checkbox for the aimbot. Now that's pretty cool. All right. So what's next? We want to create our aimbot, but for the aimbot to work, we need some entities and their positions and our local view angles. We need to control a lot of these factors. So below our draw menu, we will create a new method. Now this method will be called void update entity. In the parameters, we will have one parameter which is called entity. So we will take this entity and update all of the attributes that we have. And we will actually add one attribute that I forgot to show you guys, and that's the name. So it will be a public string name and then get set. So my apologies for not remembering that, and we will continue with the added attributes. So within this update entity, we will change the live state attribute to swedz, and we need to remove the commented out. So in the last episode we added comments to this, and we will remove them now because we want to use the swedz class to read data and so on. So here we will write swedz with lower case letters and swedz.read int, because the live state we were reading it as an int. We will have the entity's address at this point. We will add it once we read through the entity lists and so on. And don't worry that it's not known here yet, but we will add it. So we have an address when we execute this method, and if the live state is less than 1, which means he's dead, we will return. So we will end this method's runtime. Now this live state variable or value will change according to the type of entity, but what they all have in common is if it's below 1, it means the entity is not alive. So if it's not alive, we end the method early, like this. Now we will read some more information, which will be the position. So the origin is the 3D position of our character's feet. So it will equal to swedz, and then the very neat read vec for vector. We have the entity's address, and we know the offset is in our offsets class under origin, the same. We will get the vOffset attribute with swedz.read vec as well, entity.address. The offset will be nothing less than vOffset. Now that we have both the origin and the vOffset, we can calculate the abs position, or wherever it is that I'm calling abs position, and that will be the sum of the origin and vOffset. So the entity.abs equals to, and now we will use the vector3.add. This will add two vectors together, and it makes it easier for us. Entity.origin, and then the entity.vOffset. There we go. So we have the abs position. Now we will read some integer attributes. So the entity.health, we will need, it will be swedz.readInt, entity.address as the base, and then the offset will be offsets.health. It's pretty straightforward. We just use the offsets to read or to copy all of the data and into our own entity class. Now we have the health, we want to use the team number to tell if it's an enemy or a teammate. It's also an integer, entity.address, and then offsets.teamnum. We have the entity.jumpFlag to tell if the enemy is in the air or not, which will be the entity address, and then the offsets will be jumpFlag. Here we go. Now for the next attribute, which will be the entity name, it's actually, or I didn't find it with Ghidra. I should probably have researched the entity name and so on, but I found a substitute for it. Now I have Sheet Engine open, and of course I ran the game with -insecure, as you should as well. And if we spawn a zombie, sb sheets c spawn common, we have a zombie here, and we look into the entity list, Ctrl B, Ctrl D, Ctrl N. We have all of the players, so on. But if we use Ctrl F and then search for infected, we can see the pointer to the infector, and within this infected at 10 in hex, you can change the type. It's supposed to be a pointer. You can see all of these pointers. I looked through these pointers, and if we look one step into the offset 10, you can see a string title of infected. So what we will do is we will read into this offset and then read some bytes. I think we can read 10 bytes, should be enough, and turn it into a string. Now this will tell us if it's an infected, common infected. So we'll go back to the program. we create a temporary variable, entity string pointer. I'm looking for a better solution than this, so if someone knows the correct answer for the correct offset of the entity name, please let me know in the comments. We can fix it. Read pointer, and then entity address, and 10. So we have read into this pointer, and now we can read the pointed to addresses bytes. So we will set the entity.name into, and then encoding dot get string. I'm back. So we get the string from the encoding, and we turn our swedz.read bytes. We return the bytes that we seek, which will be found in this entity string pointer, and the amount, which is an integer. So we read 10 bytes and we convert these into a string. There we go. So we have all of these attributes now updated each time we run this method. So we need to also somehow get or read all of these entities. So if we take a look into the entity list again, we knew that all of the entities were 10 in hex apart from each other. So the next entity should be here, so on. If we go down, we can see it, yes, 120. If we go later down, 130, 140, you can see the pattern. So what we do is we just take this address and add 10 each time to continually just go down and get all of the entities. Now, this entity list is pretty long, so what we will do is actually read 850 potential pointers to check if they are an entity or not. I think there is a number to get the entities amount, but I don't have that, so we will just set a static or a constant value of 850 entities to look through. All right, let's get into creating this update entities method. So create a new void. We will call it update entities. In this update entities, we will create a for loop to go through all of these entities. The I will equal to 0, and whilst I is less than 850, we're looping through 850 potential pointers or potential entities, we will create a new entity, and we will set the entity dot address to the current pointer now, or the current value or address of the pointer. So we will read into it and check if it's going anywhere. It can return 0, and that would mean it's going nowhere, and we can sort these faulty pointers out. So we will get the address from swedz.read pointer, and we will add the client to the offsets dot entity list. I don't know why it's suggesting an array. but we will also have the offset I times 10 in hex. So for the first step, it will take the first entity in the list. For the second one, it will add 10 in hex. So what's happening is when, let's see if I can, no, I don't think I can. Yeah, I can. So when we go through this list, I is 0 at the first. That means we go at the first pointer. When I equals 1, it will be 1 times 10. So it will be the survivor bot. When it's I equals 2, it will be the next survivor bot, and so on. So it will add 10 each time it loops. Alright. I hope that clarified some things, and we can continue. So, if this pointer leads to anything, we can check that by if entity.address equals to intPointer.0. So if it's empty, leading nowhere, we will continue. Now, if it did, let's add a comment. Go to next entity. If we found an entity, we will update it. We have our update entity method, and we can now put in our entity object that we created. So this entity object will now have all of these attributes. Now, if the entity isn't alive, we can also just go to the next entity and skip searching. So the same question as earlier. If life states below 0, continue. So it's not return this time, it's continue. Alright, now that we have filtered out the pointers that lead nowhere and the dead zombie, we can check whether we should have the entity on our team or the enemy team. But I think we need some constants for that. Let's go up to the class variable stuff and add some new integers. So we will call this survivor team and equal that to 2. We will have a second variable which will tell us if the entity is on the infected team, which will equal to 3. So all of the zombies, including the special infected, will have 3, the survivors will have 2. If our entity is a teammate, so if we check entity.teamNum to equal survivor team, and I also perform a health check here, so greater than 0. I don't think it matters, but let's add it anyways. We will add it to the survivors like that. Now, if however the entity .teamNum equal to the infected team, we will check again if it's a common infected or if it's a special infected. So if you remember the common infected had a string that said infected at the offset 10 was a string pointer. So we will just check the name, if entity.name, and if it contains, we'll check infected. If it does, we will add it to the common infected list. If it is, or if it, however, was a special infected, which will be all of the other cases, we will add it to the special infected instead. So we have now a method to loop through 850 pointers, check if the pointer leads nowhere or if the zombie is dead, and if it isn't dead, we will add it to our list and it will be stored up here. We can access these from another method. I think we should test these now to check that everything is working, but I think we need a new method to collect all of these, to run all of these other methods. So we will go into the main, static void main, and we will create a new thread. So we will call this the main logic thread for the lack of a better name. New thread, and it will call the program dot, and we haven't created the method yet, so let's go up here and above the draw menu we will create a new method called main logic, like this, just to satisfy the compiler or the editor. Dot main logic, it will run in the background. Is background equal to true? We will start it, and now when the application runs, we should do all of this stuff and then run this method. Now in this main logic method, we will want it to always run. It will be our main loop, sort of. So in this main logic method, while it's true, or actually before, we will get the client module or the client pointer from swedz.get module base, or the, not the pointer but the module base. We'll use the swed class method, and we will just write client.dll like that. We will write the engine, or distribute the base to the engine as well. Module base, and then engine.dll. Alright, so we have the base of the client and the engine. Now we can check if these entities are working, but we don't have, or we haven't added information to get the local player. So actually one last method in the updating entities business, which would be called reload entities. That's my bad, guys. This will just clear the lists, and so we can add more entities to them. Otherwise the lists would just continue to pile on. Common infected, special infected, clear. We have the survivors dot clear. Let's go back. And let's add our local player into the equation. So the local player's address will be swedz.read pointer, because we needed a pointer. And we use the client and then the offsets dot local player like that. Now we have the address tied to the local player, and we can update the local player with the update entity method. What do you look at that? So we can also update the entities here, and we can now call this from our main logic, load entities, and we can add a breakpoint to see if it collects our entities as it should. So it should add the survivors into the survivor entity list. Oh yeah, I should mention that it might not be a good idea to breakpoint when you have the overlay there, because it might freeze the window that's on top of the screen. But we haven't added the overlay yet, so we're fine. And the debugger hit the breakpoint, and we can add our survivors to the list. And you can see here that it says count free. That's very exciting. Now we can see some information. So here we see some health, we see a jump flag, we see a life state of a very big value, but it's greater than 0, so he's not dead. We have a position. We even have a view offset. We have a team none, and it's 2 because it's a survivor. Let's look into the others. So they all have 100 health, and in the game they should have 100 health as well. We also have a zombie here, so let's take a look if the breakpoints also hit the zombies. So we will add common infected list, and you can see our count 1. That's amazing. Here we can see the name infected. The jump flag is 1 here. We can see the address. We can see the abs position. We can see the origin. Here we can see the view offset 41. And it all looks amazing this far. So we have all of this information about these entities. And let's check if we can find a special infected as well. So let's spawn in our charger. Yeah, here's going at it. Let's run it. You need to rerun it now because new data is added. So we still got old entities, and we have our special infected list that it says 2 here, which is a bit weird. It should just say 1, but we can see here that it has 600 health. Jump flag is something, we don't know. The name is wrong, but it still carries the information. So let's take a look at the next one. It says health here 0, so we might, the life state is still above 0, so we might actually add a check for that while we're here, so we don't forget it. We go back into the update entities. We go into this here, and we add else if entity dot entity dot health is above. We should just have a No, never mind. We have an else here, and we check inside here if entity.health is greater than 0. So it's a bit of a bad solution, but now we shouldn't get these false entities. So if we add the breakpoint again, run it, let's see if the charger is still here, and we have one in the special infected category. We have the, here we can see 580 health. Let's shoot him a bit, and he should have less health now. What do you complain? Where did that arrow come from? Oh, it was me. So let's run it again. And he has 194 health now. So this is pretty amazing so far. We have the position, we have the app's position, we have a lot of information now at our hands, which means we can calculate the angles now to aim at the entity. And we also have the view angles to change from our offsets right here. So let's create, or maybe I'll take a quick break. I'll pause the video for me, but for you guys it will be instant. So see you guys. Alright, so the second part, I've now taken a quite large break and I'm ready to go back in. Now we updated the entities and now we want to aim at an entity. So the way we will sort the entities are by magnitude in this tutorial. So later tutorials we will use the crosshair and take the one closest to crosshair, but in this video we will take the closest entity or zombie and aim at him. So how do we calculate the distance? A straight line towards the enemy, that distance. It's actually quite easy. Let me show you guys. It's only one line of code. So let's move down a bit, and above the reload entities we will create a new method which will return a float. It will be the magnitude, the float value. So it will be named calculate magnitude. It will, I need to change the keyboard to Swedish. Here we go. It will have the parameters from, it's a vector 3, and then destination. There is better names for this. I just didn't care at the moment of creating this. So we'll have them, or these names, this time. Now, how do we calculate the straight line or the straight distance from a 3D point to another? And we do that by taking the square root of delta x to the power of 2 plus delta y to the power of 2 plus delta z to the power of 2. Because if you remember the hypotenuse, it all comes together. So let's write it in code. We will return a float again. This float will be the square root of math.pow, and we need the delta x now. So destination.x minus from x to the power of 2 plus math.pow destination y minus from dot y plus, and we need the second argument to the power of 2 plus math dot pow, and the last one, which is the z-axis, destination dot z minus from dot z to the power of 2, and one more parentheses. So this will get us a straight line to the enemy. Now we have the magnitude, and we will have to add it to the entity. So we have all of these things, but we actually have the magnitude. So we already have a magnitude attribute for the entity. Let's add it to the update entity method. So let's add it here, entity.magnitude, which will equal to calculate magnitude, and then we will use entity dot origin, and then our local player, so the destination from our local player and his origin position. So it's important we run the update this will just return a 0 if it's the local player, so it doesn't matter if we're updating the local player. But if it's an entity, it will return the distance between you and the entity. So now that we have the magnitude, we can easily find out which one is the closest, and that's by sorting the list. We have a list of entities, we have the magnitude of each entity, and we just need to sort them by magnitude. So go into the reload entities method, and when we have updated all of the entities, we will perform we will do the following. So we have the common infected, which will equal to common infected dot order by. Now in this order by parentheses, we will write O equals arrow O dot magnitude. This will sort by the magnitude and its lowest to highest in this case. So we will do exactly the same for the special infected, equals to specially infected dot order by O equals sign arrow O dot magnitude to list. Otherwise it will throw an error. I think we're using lists, and just use the toList function. So now we have ordered by the closest entity, and now we need to aim at it. So we need a couple of more functions. We're almost there. We need the angles of the enemy, which we will write right now. So let's write it under this calculate magnitude. We will write vector 3 calculate angles. We're using a vector 3 here only because of the reason that in the game it's also a vector 3, if I'm not completely wrong. We will take in two 3D positions, so vector 3 from like before, and vector 3 destination. So we have the yaw and the pitch. So the yaw is your right and left 360 degrees, and your pitch is 180 degrees you look up and down, and the pitch is inverted. That's the correct terminology. We saw in the episode 2 that if we move the mouse upwards, it's a negative number. So it was minus 89 degrees when we looked up, and positive 89 when we look down. So we need to think of that while coding this method as well. And the yaw, it goes from 0 to 180, and when we go past 180, it goes negative, if I'm not completely wrong. So then it goes from negative 180 positive to 0, and then 180 again. So it goes in a loop in that motion, if I'm remembering correctly. So we will calculate the yaw here, and we will calculate the pitch here. So the yaw, we will need the angle on the x and y axis. So we will need delta x, which we get by subtracting our x from the destination's x. We get the delta y using the same method. Now that we have the delta x and delta y, we can use, let me look up what it's in English. Alright, so yeah, we will get the tan, or use the tan. I'm probably butchering that pronunciation, but we will use the tan to get angle A. The opposite and the adjacent side will be our delta x and delta y. So this means the yaw will be equal to, we will cast it as a float. We will use math.atan to get the angle from delta y and delta x, and we will multiply it by 180 and divide it by math.pi. This last calculation is because we need to convert it into degrees instead of having these. Oh, I can't remember the name for it. All right, here I have a different picture. So the unit was radians. So we get the angle from two sides, our opposite and adjacent. The angle, you can see here tan or tangent, opposite divided by the adjacent. So I assume delta y is our opposite and the adjacent is our delta x. Yeah, that would make sense. X this way and y this way. So we get the angle and it's returned in radians. An angle 0 measured in radians, which means we will need to convert it. So we convert it by multiplying by 180 and dividing it by pi. So that's how we get the angle for the yaw, and we will do the same, but a bit different in the pitch. So let's move forward, and we create a new float, which is called delta z or z. It will be destination z minus from z. Now we will have a distance, and it will actually be a double. This distance will be equal to math.square-root math.pow, and not delta z. It's delta x to the power of 2 plus delta y to the power of 2, and not the z. So we could create a method for this distance calculation. It would probably look better, but it's just the hypotenuse between, or using the x-axis and the y-axis. You should know the hypotenuse. It's this. So it's if this is a squared, or a squared plus b squared equals c squared. So we take the square root of c here. This is delta x squared, delta y is this squared, and this is the result, the distance. So our enemy, or we are here, the enemy is here. We want this one. All right. So we have the distance. Now we can create a new triangle with the distance as the adjacent and the z-axis, or the z, delta z, as the opposite. Which means the pitch, because it's negative when it was supposed to be positive, we will cast it as a float and add a minus sign in front of it. We will have math dot tangent inverse, maybe you pronounce it, 8 seems to be called here. And instead of the previous delta x and so on, we have delta z now, and the distance. So the adjacent and the opposite. Because it's radians, we need to multiply by 180 and divide it by math.pi. Why do you complain now? I've done something wrong. We need to equals like that. There we go. My bad. Now that we have the angles, we will return them as a new vector free with the yaw and pitch, and finally the z value, which will be 0 here because we don't need it. So I hope that you could follow this, and we will continue with the next methods. Now, this was the hardest part of this video, so if you managed to follow this, good job. We're almost there. We need a method to manipulate our local view angles, so let's create that real quick. The method will be called aim at. It's pretty straightforward. We will have a yaw and a pitch, or we could use the vector free. Angles like this. So we have a pointer because in the offsets, if you remember, the engine angles, or the local view angles, was from the engine module. It had the address of 4268EC, but it also had an offset, so we will need to read it as a pointer, the engine and its address, and then read it with, or write to it with the offset. So we have our int pointer. We can write var as well. Who cares? Engine angles base whatever, which will equal to swedz.read pointer engine, and then offsets engine angles. Here we go. Now we can directly write a float, not bytes. Write float engine angles base and the offsets dot engine angles offset, and then finally our pitch, which will need to be the first value, right? Let's see, the yaw is the first one, so it will be dot y. Yeah, because the yaw is usually x. Why is that? It's called angles, not pitch. My bad. Now we have the second axis, which is the x-axis or yaw, which will be the x. Now we will actually need to offset this offset by 4 bytes, because using this offset again would just write over the pitch, and we want to access the yaw, which was 4 byte in front after this float, pitch float. So now we have written the yaw and the pitch. Let's tie these things together in an aimbot method. So let's above these beautiful calculations, we will create a new method called void aimbot. This aimbot will only ask for a get async key state, and here we actually have already our aimbot hotkey. So we will check if it's pressed down, if it's less than 0, and if it is pressed, we will check if the common infected, or if there is any common infected, count is greater than 0. If there is any zombies, we will calculate the angles. We'll have the local player, and let's use the abs for this one. Local player.abs, and then we will actually subtract vector3 dot subtract common infected and the first one in the list dot abs, and then our offset vector common. So what you need to know about this argument is that we just remove, what is it, 10 units from him, so we aim a bit lower. That's all it does. You could just use the abs here. Actually, now let's leave it like that. Okay. Now we just need to call this aimbot, and I think we're ready to go. So after the reload entities, we can add a thread.sleep here, so it doesn't run at an insane speed. We will call the aimbot method like that. Alright, let's test it in game. So remember to use -insecure like always. Alright, the big reveal. So I've joined the server. You can see that back is disabled because we used -insecure. Let's pick up our big gun, an M60, and we open our program. Here, let's run it. We're not checking if we have the checkbox enabled, so the aimbot will work now at all times, even if we uncheck this, but yeah, can add the check later. That's not necessary. So the aimbot hotkey, I've chosen it to be the X button 2. And nothing is happening. Right. Okay, so yeah, I jumped the gun on this one. We're not saving at setting the angles afterwards. We need to use our aim at. My bad. Alright, let's run it. Would you look at that? And it seems like, yeah, so it's not updating properly to see if the entity is dead. Let me fix that real quick. Alright, so I can see I found a problem in the entity update. We're just reading an address here. I need to read the offsets.type state. Alright, oh my. Yeah, it's the silly mistakes. Let's run it again. Once again. And he doesn't aim at it. Alright, let's pick the big guns. And it works perfectly. Would you look at that? That's insane. Alright, let's fix the last checkbox. We can do that easily by going into our aimbot. Method aimbot. We'll just add enable aimbot like that. And now if we turn it off and hold aimbot hotkey, it doesn't work. And if we enable it, hold it down, it works perfectly. So you finally did it. You have your own aimbot now. Now it's only the ESP left to do and auto shove and be hot if we want to. But you still did it. Good job. You're awesome. If you actually followed this tutorial and made it to this moment, be proud of yourself. You did it. I don't know when the next part will be released, but I hope that this will do for the moment. Alright, see you guys later.